Section 4.1 Ratio and Proportion Applications. The compression ratio in a certain engine is 7.5 to 1. If the expanded volume of the cylinder is 45 cubic inches, what is the compressed volume? Okay, so when you compress, you're going to shrink it. So we're going to take the 45, and we are going to divide it by 7.5. And if you put that in your calculator, you should get 6. So there's another way that you could do it. You could do it with proportions, which would be something like, it'd be something like 1 compressed compared to 7.5 expanded. And then we could set it up to x, which we don't know compressed, the unknown compressed, compared to the 45 expanded. And then you would just cross multiply and divide. This way right here hopefully makes sense. You take the big number, you're compressing it, you smush it by a factor of 4.5, and you get a 6. Hopefully that makes sense. You can use your calculator on that one. Now let's try the next one. If 45 tapered pins can be machined from a steel rod 12 feet long, how many tapered pins can be made from a steel rod 6 feet long? Okay, so we know that we can get 24 tapered pins. And we put that's when using a 12-foot long steel rod, right? 12-foot long steel rod. You can put steel rod. I'm putting more information here than is necessary. Just trying to be explicit about what I'm doing here. And then what happens is, well, they say we only have 6 feet steel rod, right? Steel rod. And the question is, well, how many tapered pins can we make out of that? And I'm just labeling everything to show you, right? So we put the taper pin on top, make sure the units match. Taper pins. On the bottom we put steel, feet of steel, right? And then what we do is we would cross multiply and then divide if we were to do it this way. I've set this up. I label things to make sure that you understand where to put the units. So we have compressed at the top and compressed at the top, and we have expanded at the bottom and expanded at the bottom. And that shows you that this is the correct way to set it up. Okay, so again, make sure that your units match on the top and your units match on the bottom. At this point, you would just cross multiply. Right, so you're saying 7.5 times x, which gives you 7.5x. And then you'd say 1 times 45, and that would give equal 45, which is 1 times 45. At that point, you would divide both sides by 7.5. These would cancel out, and that would give you x is equal to 6, which is exactly what we got over there. Okay, so again, I labeled everything thoroughly, not because you have to label everything thoroughly. I'm just trying to make the point that make sure your units match on the top and the bottom. If you can do that, then you probably set it up correctly, and then you can just cross multiply and divide. So after that, I'm just going to actually kind of get rid of them. So we actually have 24 over 12 is equal to x over 6. And you can simplify this, right? And I'll put this little thing there for 24 divided by 12 is just 2, so that's really just 2 over 1. And you get x over 6. You don't have to do that yet. You can just cross multiply at this point if you want to. But these numbers are going to be a little nicer if you do this right. So it's going to be 1 times x, which I really should have given myself more room there. And then you're going to have 2 times 6, which is 12, right? Let's say you didn't simplify it. 24 divided by 12 is 2 over 1. Now, when you're dealing with ratios, you need to keep the top of the number. You're comparing two different things, right? If I say something has a 2-to-1 ratio, that's how you read that. If I lose the denominator, I'm just having 2. Well, I broke the comparison, right? I'm trying to compare two things. So this is one of those instances where even if the fractions theoretically would have reduced and you would have gotten rid of that one denominator, you don't do it whenever you're doing ratios or proportions, right? You need to keep the denominator because you're comparing two different numbers. So we want to keep that one in the denominator. Okay, so I just want to point that out. Okay, now, let's say you didn't simplify that. Let's say we instead said, well, 12 times x is 12x, right? And then we say 24 times 6 is 144, and then we say divide by 12. We say divide by 12, cancel, cancel. I expect you to use a calculator, by the way, so hopefully this kind of makes sense. You get the same thing. So whether you simplified it, the ratios and then you solve the proportion, or you just cross multiply and then divide, it works out. Okay, so let's try the next one. And again, I'm thoroughly labeling everything, not because I expect you to, but I'm just trying to make the point of how to set these up. So this one's saying, for a certain kind of plasterwork, 2.5 cubic yards of sand are needed for every 100 square yards of surface. How much sand will be needed for 360 square yards of surface? Okay, so what we have here is we have 2.5 cubic yards of sand. Okay, and again, I'm thoroughly labeling everything just to make the point. And this is for square yard surface. Okay, so that is that comparison. Okay, and let's see what they give us there. They're saying 360 square yards of surface. Well, where does that go? It goes on the bottom with the other square yards of surface. So it's 360 square yard surface. Okay, I'm just trying to make sure we know where to put the numbers, and the unknown is right there. Okay? And they say, how much sand? Well, that makes sense. That sand's going to be on the top. It's the x. Okay, cool. We set it up correctly, almost certainly. Now we move on. So I'm going to remove the units. I'm going to remove all that extra descriptor there to just make the calculation easier. Oops, a little bit too much. Okay, and the x goes down here, and the 360 goes there. Okay, so again, I did all this description just to make sure sand goes on the top, surface goes on the bottom, cubic yards goes on the top, square yards go on the bottom. Okay, cool. Probably set it up correctly. Okay, now I can simplify these a little bit if I want to, but or I can just cross multiply. So let's just do it the simple way, right? So I'm going to say 100x is 100x. 2.5 times 360 is 900, and then we're going to undo the multiplication of x by 100 by dividing by 100, and whatever we do to one side, we do to the other. 100 cancels out on the left, leaving me an x. And the two zeros over here cancel out with two zeros over there, right? 900 divided by 100, how many hundreds do you have? I have 9, right? So 900 divided by 100 is 9. So there we go. And like I said, you could have simplified the 2.5 over 100 if you wanted to, but it's not necessary. Again, you are expected to use a scientific calculator. Even a 4-function calculator would probably do this for you pretty nicely. Okay, again, I'm going to thoroughly label everything to make a point. So it says, a 10-foot bar of I-beam weighs 206 pounds. What is the weight of an 11-foot length? Okay, so we say 10-foot bar. Okay, and it weighs 206 pounds. Okay, and then they give us a 11-foot length. Well, where's that going to go? It's going to go on top, right? So it's 11 foot, and that's also a bar. They didn't say that, but we know it's a bar. And the part we don't know is down there, right? So this is what is the weight? Well, the weight's going to be this pound here, right? The pound, unknown pounds. Okay, cool. So we set it up. Now I'm going to remove all the units. You can just cross multiply. You can ignore. I'm just doing this so that hopefully it's clearer what is happening here. But you could just cross multiply right there if you want to say 10 times x is 10x, 20 times 11 is 220. You could do that. I'm just removing it for clarity's sake, but you don't have to. Okay, so 10 times x is 10x. And we say 11 times 206, 2,266. We divide both sides by 10. And what that leaves you with is x is equal to 226.6 pounds. And there we go. So, if you earn $588.70 for a 29-hour work week, how much would you earn for a 40-hour work week at the same hourly rate? Okay, so on the top, I'm going to put dollars of 588.7, and on the bottom, I'm going to put 29 hours. And then on the right, I'm going to put 40 hours, and that's going to go on the bottom to match the hours on the bottom of the other one. And the one I don't know is the dollar X amount of it. Because it's asked, how much would you earn for a 40-hour work week? Okay, so how much would you earn, which is X number of dollars. Let's rewrite this without all the units. You don't have to do this, but I'm just trying to make sure it's not any more confusing than it needs to be. So you're saying 29 times x, which is 29x, is equal to 588.7 times 40. Put that in the calculator, and it gives us 23,548. And then what we do is we divide both sides by 29. And what that does is give you an x, right? 29 cancels out with 29. X is equal to 8 12, even.